Now we're ready for higher order derivatives. Let's first look at the different notations for these derivatives. We're going to use the generic f of x as our function. So our first derivative, we can show it as f prime of x. Or we can also use Leibniz notation, where it's the derivative of y with respect to x, so d of y over d of x. Or you may see it as d over dx f of x. Now, one thing that I want us to recall is that the derivative is like our slope. We're looking at the change of y over the change in x. Now, for our second derivative, we would use two apostrophes, or we can say f double prime of x. But notice what happens in the Leibniz notation. We would have d squared of y over d of x squared. So notice in the Leibniz notation, the d has the square to it, noting the second derivative, but it's the x that is squared because it's with respect to x squared. The reason is, if we look at the slope, change in y over the change in x, but now we're taking the derivative of that, so it's the change of that slope over the change in x. If we're wanting to get rid of that change in x in the denominator, we would have to multiply the top and bottom by that change in x. So that would give us the change in the change of y, or twice the change in y, and then change in x times the change in x. X in x, x squared. Now the rest of the derivatives follow suit. So the third derivative would be f triple prime of x with d cubed of y over dx cubed. And honestly, these first three derivatives are what we're going to probably see more than anything in the majors that we're working with. But just so you know, if we're looking at the fourth derivative, we would stop using primes because it would get too many to count. So we would just say f to, let's say, fourth derivative, we'd put 4 in parentheses of x. Leibniz continues in the same format, d to the fourth of y over dx to the fourth. So for any nth derivative, we would write it as f to the nth in parentheses of our x. And in Leibniz, d to the nth of y over dx to the n. Now let's look at the concepts of our higher order derivatives. Now derivatives are functions themselves, thus we can take a derivative of a derivative. So suppose P represents the population of turtles in T years. Then P of T would represent the number of turtles at time T. P prime of T, or the first derivative, would represent the rate at which the number of turtles is increasing or decreasing at time T. We can think of the first derivative as the velocity. So that rate would be in turtles per year. Now, if we were to take the derivative of that derivative, in other words, the derivative of the velocity, that's telling us how quickly that velocity is changing. We can think of this as acceleration. So the second derivative of P of T represents how quickly or slowly the number of turtles is increasing or decreasing at time T. The units would be turtles per year, or turtles per year squared. So let's take a look at these examples here. Let's suppose we say f of x represents distance. Then the derivative f prime of x would be the velocity. And then the double prime or second derivative is acceleration. So think of those car commercials. We know our car can go 60 miles an hour, but acceleration is when they say we can go from 0 to 60 in 3 seconds. That's acceleration. There is a special name for the third derivative. It's called the jerk. It represents the rate of change of acceleration. Think of that jerky motion when there's a drastic change in your acceleration, like in your car or in your motorcycle. That is a third derivative. So let's find the first three derivatives of this function where f of x equals 2x squared minus x cubed. The first derivative would be 4x minus 3x squared. The second derivative is merely the derivative of the first derivative, so we'll do it again. The derivative of 4x would be just 4, and the derivative of 3x squared would be a negative 6x. Then the third derivative, if we take derivative of a constant, that's 0. The derivative of a linear term would just be the coefficient of negative 6, which would just be negative 6.